Alright, in this video we're going to look at converting degree measurements to radian measurements and vice versa. So to find the relationship between radians and degrees, we take a look at one full rotation of of our circle, or the entire pizza, using the pizza analogy. And one full rotation is going to be the entire circumference of a circle, the entire distance around a circle, which is 2 times pi times the radius. And going all the way around the circle is, in terms of degree measurement, is 360 degrees. So these are two variations on the same theme: the distance around the circle and the total number of degrees rotated. So by setting them equal to each other, and keeping in mind that we're looking at when the radius of the circle equals the length of the intercepted arc is 1 radian, we have 360 degrees equals 2 pi times radians. So if we divide both sides by 2 pi, or excuse me, we divide both sides by 2 rather, we get 180 degrees is pi radians. So a half a circle is pi radians. And if we want to know what 1 radian is, we can just take 180 degrees and divide it by pi, and we'll get what 1 radian is. Now, if you type in 180 divided by pi, you're going to get approximately 57.3 degrees. So what that means is if you have a pizza, and it doesn't matter how large the pizza is, a round pizza, it doesn't matter how large the round pizza is, if you make a central angle that's about 57.3 degrees, then the length of your slice's crust will be pretty much equal to the radius of your pizza. So to convert from degrees to radians, we're going to multiply by pi over 180. So we have our conversion factor where we have 180 degrees as pi radians, kind of like if we want to convert from, let's say, feet to miles, or milliliters to liters, which is a lot easier, but it helps to have this conversion factor for the ones that aren't easy. So if we start with degrees, let's say we're converting 10 degrees to radians, we want the 10 degrees and the 180 degrees in the denominator, we want those degrees to cancel out, leaving us with radians as our unit that's left over. Now, typically we don't write radians. Sometimes we write rad after the pi, but if there's nothing there, assume that the measurements in radians. So here we have the degree symbol indicating it's 180 degrees, but we typically don't write radians or even rad after the pi. To go backwards, just multiply by the reciprocal. So if you started with radians and you want to know how many degrees that is, multiply by 180 degrees over pi radians. So it's all about your units canceling out. So we'll see that here in the next couple problems here. All right, so example 1, convert each angle to radians. So 30 degrees, this is going to be one that we see quite a bit of. How many radians is 30 degrees? Well, we're going to start with 30 degrees, and we're going to multiply this 30 degrees by pi over 180. So notice this degree symbol here is going to cancel out with this degree symbol in the denominator, and we'll have 30 pi over 180. Now we can reduce 30 over 180 as 1/6, so pi over 6. So we will see 30 degrees quite a bit in here, which it might be helpful to start keeping some of these conversions in mind. Pi over 6 radians is 30 degrees. Part B, 90 degrees. Well, same thing. We're going to start with 90 degrees, and we're going to multiply it by pi over 180, so our degree units cancel out. So we'll be left with 90 pi over 180, and 90 over 180 is 1/2, and we can write that as pi over 2. So another common angle measurement we're going to see in here is 90 degrees, which is pi over 2 radians. So part C, negative 135 degrees. So remember, in trigonometry, our angles can be negative, which just means they're opening to the right or clockwise. So we're going to convert them the same way, multiply by pi over 180. Our degrees are still going to cancel out, and we'll have negative 135 pi over 180, and negative 135 over 180 is negative 3/4. So we'll just put the pi symbol back when we're done, and we get negative 3 pi over 4. Positive 135 is just positive 3 pi over 4. So really the negative sign is just indicating direction of rotation. It doesn't change necessarily the values here, except it becomes positive. All right, example 2, we're going to work backwards now. We're going to start with our radians and convert them to degrees. So this will be very helpful when you see radian measurements, and until you start getting comfortable and familiar with them, it might be helpful to work with them in degrees and think about them in terms of degrees. So we have pi over 3 radians. We're going to multiply that by the reciprocal of pi over 180 is 180 over pi. So notice the pi radians up top and the pi radians in the denominator. Those pi radians are going to cancel each other out, leaving us with 180 degrees over 3. And 180 degrees divided by 3 is 60 degrees. So pi over 3 radians is 60 degrees. And again, these are very common angles that we will see quite a bit of in here. All right, finally, part B, negative 5 pi over 4. We're going to multiply that by 180 degrees over pi. Once again, the pi radians are going to cancel out, and negative 5 times 180 is negative 900 over 4, which is negative 225 degrees. So, all right, that about does it for this video. Thanks for watching, and I'll see you next time.